Hello! Today we're going to continue to take the practical lessons with 3D modeling. To guide you with this subject will seminar teacher Domina Inessa. Today's seminar topic is Standard and Extended Primitives, Operation with Objects, Commands of Compound Objects. After completing this chapter you'll be able to understand selection techniques, create standard primitives, create extended primitives, create compound objects and modify compound objects. In this chapter you'll learn to create the default 3D objects called standard primitives. Thus geometric primitives are parametric objects. You will learn to create complex 3D shapes using extended primitives. Also, we'll learn how to create complex models by combining two or more existing objects into a single object. The different techniques explained in this chapter will help you to combine different 2D and 3D shapes that would otherwise be difficult or impossible to do. So, let's get started with selection techniques. Here on the top, on the main toolbar, you can see 8 icons related with selection. Oh, how it is possible, probably you may ask. 8 buttons for only selection purpose? Yes, the software Autodesk thought Max so smart created, and everything here designed for comfortable work with objects. And each selection button have a different characteristics. So please, pay attention for it, for not to get confused in those commands. The Select Object tool is used to select one or more objects in the viewport. To select an object, choose this tool and move the cursor over the object. The cursor will convert into a selection cursor. Next, press the left mouse button. The object will be selected. To select more than one object at a time, hold the Ctrl key and select the object that you want to add to selection. To remove an object from the selection, press and hold the Alt key and then click on the object that you want to remove from the selection. The Select by Name tool is used to select an object from the list of objects in the scene. When you choose the Select Object by Name tool from the main toolbar, the Select from Scene dialog box will be displayed. If there are some components in the scene, then those components will be displayed in this dialog box as shown in figure. Now, select an object in the list and choose the OK button. Alternatively, you can double-click on the object's name in the list to select it. You can also select more than one object by holding the Shift or Ctrl key. The buttons at the top of the dialog box are used to filter the objects in the list. The Select and Move tool is used to select and move the objects in the viewports. You can move an object by selecting it and then dragging the mouse along the X, Y, or Z axis. You can also move the selected object in the XY, YZ, or ZX plane. To move the selected objects along one of the axes, choose this tool and then select the object. The Move gizmo will be displayed. Move the cursor of the axis along which you want to move the object. Press the left mouse button and then drag the cursor. Similarly, to move the objects in one of the planes, move the cursor of the plane displayed between the two axes. The plane will be highlighted in yellow. Next, press the left mouse button and drag the cursor. The Select and Rotate tool is used to rotate the objects in the viewport along the X, Y, or Z axis. To rotate the objects along one of the axes, choose the Select and Rotate tool, and then select the objects. A rotate gizmo will be displayed along with the X, Y, and Z axis. Next, move the cursor of the axis along which you want to rotate the object. Press the left mouse button, and then drag the cursor. When you rotate the objects, a transparent slice will be displayed, which will provide a visual representation of the direction and the degree of rotation. Also, you can view the degree of rotation in the X, Y, and Z axis in the coordinates displayed in the Coordinate Display area at the bottom of the screen. The Select and Uniform Scale tool is used to scale the objects proportionally along the three axes. To scale an object uniformly along all three axes, choose the Select and Uniform Scale tool from the main toolbar and select the object. The scale gizmo will be displayed. Move the cursor to the center of the gizmo and make sure its central portion is highlighted. Next, drag the cursor up or down to scale the selected object. You can also perform non-uniform scaling using this tool. To do so, move the cursor of the axis along which you want to scale the object, and then drag the cursor similarly. You can perform non-uniform calling along the XY, YZ, or ZX plane by selecting the required plane, and then dragging that plane. The Select and Non-Uniform Scale is used to scale an object along a particular axis or plane non-uniformly. To scale the object, choose the Select and Non-Uniform Scale tool from the Select and Scale flyet, and then select the object. Move the cursor of the X, Y, or Z axis along which you want to scale the object, and drag the cursor to modify the shape of the object. Similarly, you can perform the non-uniform scaling along the XY, YZ, or ZX plane. You can also perform uniform scaling in the same manner as described in the Select and Uniform Scale tool. The Select and Squash tool is used to stretch and squash the object along the selected axis. To squash the object along one of the axes, choose the Select and Squash tool and select the object. Move the cursor of the axis along which you want to squash it. Next, drag the cursor. Similarly, you can squash the selected object along the XY, YZ, or ZX plane. To do so, move the cursor over the plane displayed between the two axes and drag the cursor to squash the object along that plane. Note: by default, the color of the transfer gizmos of the X-axis is red, the Y-axis is green, and the Z-axis is blue. When you move the cursor over any one of these axes, it gets activated and turns yellow. You can see the colors of those axes displayed at the bottom left corner of each viewport. Also, the colored axes are displayed while selecting an object using the Select and Move, Select and Rotate, or Select and Scale tool. Select and Place tool. This tool is used to position and orient an object with respect to another object. The placed object changes its orientation according to the shape of the object on which it is placed. To place an object on another object, choose the Select and Place tool from the Select and Place slide in the main toolbar, and then click and drag the object to the other object. You will notice that the shape of the cursor has changed. On achieving the required orientation of the object, release the left mouse button. The selected object will be aligned with the other object along that axis. So now, when you learn how to operate with objects, let's create these objects. Standard primitives. Softmax has several basic three-dimensional geometric shapes, which are known as a standard primitives such as box, cone, sphere, cylinder, torus, tube, and so on. You can use these primitives to create simple 3D models, such as table, box, chair, and so on. All the standard primitives can be created dynamically, using the mouse or by specifying the parameters in the keyboard entry, rollout of the command panel. To create the standard primitives, choose Create Geometry in the command panel. By default, the Standard Primitives option is selected in the drop-down list below the Geometry button. Now, activate the viewport in which you want to create the primitives. Next, choose the corresponding tool from the object type Rollout. In the following section, you will learn how to create and modify the standard primitives using various tools available in the object type Rollout. Here, we will be introduced with some objects and their parameters, and you guys will study by own other objects which I not described. Also, here is some tips for you. If you are creating a primitive that requires multiple steps, you can pan or orbit the viewport in between the steps. To pan the viewport, drag the cursor with the middle mouse button or mouse wheel held down. To rotate the viewport, press and hold the Alt key and then drag the cursor with middle mouse button or mouse wheel held down. Creating a box. To create a box, activate the viewport by clicking in it. Next, choose the Box tool from the object type Rollout. The name and color, creation method, keyboard entry, and parameters rollouts will be displayed. Press and hold the left mouse button in the viewport to specify the first corner of the box, and then drag the cursor to define the length and width of the box. Release the left mouse button to get the desired length and width. Now, move the cursor up or down to define the height of the box. Click after you get the desired height. The box will be created as shown in presentation. Note: to view all the rollouts, position the cursor over any of the rollouts until you see the pen icon hand. Next, press and hold the left mouse button and drag the cursor in the rollout. Secondly, the plus sign on the left side of the rollout head indicates that the rollout is collapsed, and the minus sign indicates that the rollout is expanded. Various rollouts used to create and modify the box are discussed next. Name and color rollout. In Autodesk Softmax, a specific name and color is automatically assigned to the newly created box. To modify this name, expand the name and color rollout. Enter a new name in the text box available in this area, and then press Enter. To change the color of the box, choose the color swatch on the right side of the text box. The Object Color dialog box will be displayed. Choose a new color from this dialog box. The selected color will be displayed in the current color swatch. Now choose the OK button. The new color will be assigned to the box. To customize the color, choose the Add Custom Colors button in the Object Color dialog box. The Color Selector Add Color dialog box will be displayed. Now customize a new color in this dialog box and choose the Add Color button. The new color will be displayed in one of the color swatches in the Custom Colors area of the Object Color dialog box. Next, choose the OK button. The new color will be assigned to the box. The options in the name and color rollout are same for all the standard primitives. Creation method rollout. The options in this rollout are used for creating the box dynamically using the mouse. By default, the box radio button is selected. As a result, you can create a box having different lengths, width, and height. Select the cube radio button to create a box of equal lengths, width, and height. Keyboard entry rollout. This rollout is used to create a box by entering the parameters in the keyboard entry rollout. Using the keyboard, the lengths, widths, and height spinners are used to specify the length, width, and height of the box. The X, Y, and Z spinners are used to specify the position of the box in the viewport along the axis of the home grid or of a grid object. By default, the value in these spinners is 0. Therefore, the object will be created at the center of the home grid or of a grid object in the viewport. The Create button in the keyboard entry rollout is used to create a box in the viewport of specified dimensions. Parameters rollout. After creating the box, you can modify its dimensions using the parameters rollout. The length, width, and height spinners are used to specify the length, width, and height, respectively, of the box. The length X, width X, and height X spinners are used to define the number of divisions of segments along each axis of the objects. By default, the Generate Mapping Coordinates checkbox is selected by default. As a result, mapping coordinates are created automatically with a projection appropriate to shape of the box. You can select the Real World Map Size checkbox to correct the scale of the texture mapped materials that are applied to the box. This option lets you create a material and specify the actual width and height of a 2D texture map in the material editor. After creating a primitive, you right-click in the viewport to exit the tool. The parameters rollout will disappear from the Create tab. In such a case, to modify the parameters of the primitive, select the primitive in the viewport and choose the Modify tab from the Command panel. The parameters rollout will be displayed. Axis Constraints toolbar. The buttons in the Axis Constraints toolbar are used to specify the axis or plane along which the transformation would be restricted. The transformation includes movement, rotation, and scaling of an object. The Axis Constraints toolbar is not displayed by default in the interface. To display it, right-click in the blank area in the main toolbar. A shortcut menu will be displayed. Choose Axis Constraints from the shortcut menu. The toolbar will be displayed on the screen. Now, choose one of the buttons available in the Axis Constraints toolbar to perform the transformation along the selected axis. You can use the F5, F6, and F7 functions key to invoke the X, Y, and Z constraints. To toggle between the XY, YZ, and XZ axis, you can use the F8 function key. Extended primitives. In Source.Max, there are some complex 3D geometric shapes, which can be used to create 3D objects. Those shapes are known as extended primitives. The extended primitives are chamfer box, spindle, hydra, and so on. To create an extended primitive, you need to choose Create, Geometry from the Command panel. A drop-down list will be displayed with the Standard Primitives option selected by default. Now, select the Extended Primitives option from the drop-down list. Activate the viewport at which you want to create the primitives, and then choose the corresponding tool from the Object Type Rollout. In this section, you'll learn to create and modify the extended primitives using various tools available in the Object Type Rollout. Here I'm going to describe some of them, and you, by own, will study remaining extended primitives. Creating a chamfer box. A chamfer box is similar to a box in the standard primitives, with the only difference is that it has beveled or rounded edges. To create a chamfer box, activate the viewport and choose the Chamfer Box tool from the Object Type Rollout. The name and color, creation method, keyboard entry, and parameters rollouts will be displayed as shown. Now, press and hold the left mouse button at a point in the viewport for defining the first corner of the chamfer box, and drag the cursor to define its length and width. Release the left mouse button to get the desired length and width. Next, move the cursor up or down to define its height, and click on the viewport to get the desired height. Move the cursor to define the fillet and click on the viewport to get the fillet or chamfer. A chamfer box will be created. There are two radio buttons in this rollout. By default, the box radio button is selected. As a result, a chamfer box is created with individual settings for length, width, and height. You can select the cube radio button to create a chamfer box of equal length, width, and height. Parameters rollout. The options in this rollout are used to modify the chamfer box. The length, width, and height spinners are used to specify the length, width, and height respectively of a chamfer box. The fillet spinner is used to bevel the edges of a chamfer box. Higher the value of the fillet spinner, more refined will be the fillet on the edges of a chamfer box. The length X, width X, and height X spinners are used to define the number of segments along the length, width, and height, respectively, of a chamfer box. The fillet X spinner is used to specify the number of segments in the fillet of a chamfer box. By default, the smooth checkbox is selected. As a result, the chamfer box will be smooth at rendering. If this checkbox is cleared, a chamfer box will be beveled edges will be created as shown. Compound objects. In Max, the compound objects are created by combining two or more objects. There are 12 tools to create various compound objects. To create these compound objects, you need to choose the respective tools. To create a compound object, choose Create Geometry in the Command panel. A drop-down list will be displayed below the Geometry button. Select the Compound Objects option from the drop-down list. The Object Type rollout will be displayed with all the tools to create compound objects. The most commonly used tools to create compound objects are discussed next. Boolean. The Boolean is used to trim or combine objects in an operation. To carry out Boolean operation, you need two objects. The objects to be operated upon are known as operands. To create a Boolean object, first create two overlapping objects in the viewport. Select one of the objects in the viewport. Choose Create Geometry in the Command panel. A drop-down list will be displayed. Select the Compound Objects option from the drop-down list and choose the Boolean tool from the Object Type rollout. The name and color, Pick Boolean, and Display Update rollouts will be displayed. The selected object will become operand A, and the name of the object will be displayed in the list box of the operands in the Parameters rollout. Next, choose the Pick Operand B button in the Pick Boolean rollout and move the cursor over the second object or operand B in the viewport. The shape of the cursor will change into a selection cursor. Now, select the second object to perform the Boolean operation. Right-click in the viewport to exit the Boolean tool. Pro-Boolean. The Pro-Boolean tool is used to perform some advanced functions in a Boolean operation. In this process, you can select multiple objects to Boolean at a time, change the Boolean operations, and reorder the operands. The objects that are used to create the Pro-Boolean objects are called as operands. You need to perform the Boolean operations on those operands using the Pro-Boolean tool. To create a Pro-Boolean object, create two or more objects in the viewport and arrange them such as that they should intersect each other. Now, select the object on which you want to perform the Boolean operation. Next, choose the Pro-Boolean tool from the Object Type rollout in the Compound Object. The name and color, Pick Boolean, Parameters, and Advanced Options rollouts will be displayed. Next, choose the operation that you want to perform in the operation area of the Parameters rollout. Now, choose the Star Picking button in the Pick Boolean rollout and move the cursor over another object. The Boolean cursor will be displayed. Now click on the object to perform the Boolean operation. Note that the Start Picking button remains active and you can select one or more objects to perform the Boolean operation. Select other objects in the viewport one by one to perform the Boolean operation. Then choose the Start Picking button again to deactivate it. Scatter. The Scatter tool is used to randomly distribute the source object as an array or over the surface of the distribution object. To create a scatter object, first create an object to be used as a source object, and then create another object to be used as a distribution object. Next, select the source object and choose the Scatter tool from the Object Type Rollout of the Compound Objects. The Pick Distribution Object Scatter objects Transform, Display, and Load, Save, Presets rollouts will be displayed. Now, choose the Pick Distribution object in the Pick Distribution Object rollout and move the cursor over the distribution object. The shape of the cursor will change into a selection cursor. Select the distribution objects in the viewport. Next, expand the Scatter object rollout in the Source Object Parameters area. Set the required value in the Duplicate spinner to create a number of duplicates of the source object. Connect. The Connect tool is used to connect two or more objects as the wholes on their surfaces. To connect the objects, create two objects and then convert them into editable objects. Next, select the polygon or face-up object level in the modifier stack. Now, select the sub-objects of the editable objects in the viewport and then press the Delete key to delete the selected face or polygon sub-objects. Note that you need to position the objects in such a way that the holes should face each other as shown. Next, select one of the objects and choose the Connect tool from the Object Type Rollout in the Compound Objects. Choose the Pick Operand button in the Pick Operand Rollout and move the cursor of the second object in the viewport. The shape of the cursor will change into a selection cursor. Select another object. New faces will be created to connect the holes of the objects. Next, right-click to exit the command. When you choose the Connect tool, the name and color, Pick Operand, Parameters, and Display Update rollouts will be displayed. Shape Merge. In a Shape Merge object, the shape is either embedded in the mesh object or subtracted from it. To create a Shape Merge object, first you need to create a mesh object and a shape, and then align them. Next, select the mesh object and choose the Shape Merge tool from the Object Type Rollout of the Compound Objects. Next, choose the Pick Shape button in the Pick Operand Rollout. A selection cursor will be displayed that will prompt you to select the shape spline. Select the shape spline and right-click to exit the Shape Merge command. To view the Shape Merge object with the embedded shape in it, select the Shape Merge object. Choose the Modified tab in the Command panel and select the Face Extrude modifier from the Modifier List drop-down list. In the Parameters rollout of the Face Extrude modifier, set the value in the Amount spinner. The shape will be embedded in the Mesh object. To view the subtracted shape in the Shape Merge object, select the Shape Merge object level in the Modifier stack. various rollouts will be displayed. In the Parameters rollout, select the Cookie Cutter Radio button in the Operation area. The shape will be subtracted from the mesh object. Note: the Face Extrude modifier is used to extrude the faces of the selected mesh object. When you choose the Shape Mesh tool, the name and color, Peak Operand, Parameters, and Display Update rollouts will be displayed as shown in figure. Conform. The Conform tool is used to adjust the position of an object over another object, such that the object completely fits on another object according to its shape. The object that is to be positioned over another object is known as the wrapper object, whereas the object on which the wrapper object will be positioned is known as the wrap-to object. To create a conform object, you need two objects. One of those objects will be used as the wrapper object and another as the wrap-to object. Position both the objects. Select the wrapper object and then choose the Conform tool from the Object Type rollout in the Compound Objects. Choose the Pick Wrap to Object button in the Pick Wrap to Objects rollout. A selection cursor will be displayed which will prompt you to select the Wrap to Object. Select the Wrap to Object. The wrapper object will be positioned over the Wrap to Object in such a way that it fits according to the shape of the Wrap to Object. Next, you need to set the other parameters in the various rollouts displayed on invoking the Conform tool. Procutter. The Procutter tool is used to break an object into separate objects with the help of the mesh objects. The mesh objects that are used to break the object are known as cutters, and the object that is divided by cutters is known as the stock object. To create a Procutter object, first create an object to be broken into separate objects. Create one or more mesh objects to be used as cutter. Align both the objects. Select one of the cutter objects and then choose the Procutter tool from the Object Type rollout in the Compound Objects. The name and color, cutter picking parameters, cutter parameters, and advanced options rollouts will be displayed. In the cutter picking parameters rollout, choose the Pick Cutter Objects button and select the additional cutters in the viewport. Next, choose the Pick Stock Objects button and select the object that you want to cut in the viewport. The object will be cut. Right-click to exit the command. Loft. Loft is the most interesting, as per my opinion, and variable command which will give you various of models it is loft. We'll discuss this command in future while studying splines objects. Conclusions. On this point we're going to finish this practice work where we were introduced with how to understand selection techniques, how to create standard primitives and extended primitives, and how to use compound objects and operate with them. In next seminar, we'll start for modeling with using of standard and advanced primitives. We'll discuss how to create your first project, a composition of the theme Playground tools. For next exercise, we're going to use Boolean tools. If you feel to use and try another commands, so it is okay. The most important is result. So see you later. Bye bye.